How are you, everybody who is watching this fantastic video? I would like to take this opportunity to welcome you into a very interesting moment of learning higher engineering and scientific mathematics. Actually, we call it, this is the mathematics for engineers and scientists. My name is Olenjolai. It's the first time to meet me. I'm very happy to have you today. And I would like just to tell you in advance, I've prepared a very important information about higher engineering and scientific mathematics. And this is a very interesting actual subjects concerned about calculus. So I would like to take this opportunity. I'm here to teach you, I'm here to train you, and I'm here also to encourage you and to remind you some previous concepts that you've learned in ordinary diploma educations and even also in advanced secondary education. I would like to take this opportunity to welcome you into our online platform that we have our official YouTube channel that's called Tanzania Online Institute of Technology, where you can access actual contents we are creating for the undergraduates or bachelor degree students. We have a number of departments in this online school. One of the departments is called the Higher Engineering and Scientific Mathematics. And then today we have a module that's called the Advanced Engineering Mathematics, and also in some of the departments or some of the universities, institutions and colleges is called the Advanced Calculus. So the name itself of the modules or the course is actually giving you some information that we are learning something advanced. We may start with little introductions, very interesting to attract you, but after a short time you actually get lost in these advanced issues. But I want to tell you that it's not something difficult. It's just a set of instructions and techniques and tricks and tips and even different ways of learning and actual that mastering the concept. So it's not difficult. I'll try my level best to make sure that I transform them from advanced concept into simpler and simpler and simpler concept. I've been teaching this module for more than 7 to 8 years. So I've been gathering a number of questions. I will teach you the concept, and also I'll try my level best to teach you how to solve questions, and I'll be using different examples to make sure that the concept is actual, that is managed, is clearly understood and managed by the students. In case you have a question, don't hesitate, ask it. I have some physical students and also have online students. Try your level best to ask it. And remember that Olenjolai does not know everything about advanced engineering mathematics or advanced calculus. I just know a small portion of it, but I have a responsibility to teach others about what I know. Another thing that I want just to tell you that I am a Tanzanian and I'm teaching Tanzanian students partial differential questions or maybe advanced engineering calculus, advanced engineering mathematics or advanced calculus. These are actual international modules. It has been learned in different institutions, colleges and universities, but for this case we'll be using the curriculum of United Republic of Tanzania. And in Tanzania we have inactivate institutions and also you have TCU institution. Specifically, I'll be using the curriculums of Dar es Salaam Institute of Technology, in short we call it DIT, to teach this concept in the simplest way. So I ask you to join me, concentrate, and be a serious student because you will enjoy. So in this module we have a number of topics, because in departments of electrical engineering is called advanced calculus, departments of civil is called advanced engineering mathematics, in departments of electronics and telecommunication, advanced engineering mathematics, in departments of mechanical is called the advanced calculus. So we have a number of topics. Some of the topics are similar and some of the topics are not similar. But this chapter 3 or chapter 2, which is called the partial differential equation, this is a common topic for both modules. And we are going to start the first lecture that's called terminologies of partial differential equation. So let me appreciate some physical students. Okay, how are you, physical engineering students? You are good. Are you ready for lecture 1? Well, so we have a number of chapters. One of the chapters is called the partial differential equation. Say partial differential equation. And then the first lecture, we are going to start with terminologies of partial differential equation. Then let us start. Straightforward. The first terminology that we want to understand its meaning and have a short discussion is called the partial differential equation. Class A, partial differential equation. In short, we call it what? PDE. Say PDE. Partial differential equation. That's what we call terminologies of PDE. Partial differential equation. So the first question that we need to understand as engineers, this is the first question. What is partial differential equation? Before we see the examples, then what is it? What is the meaning of partial differential equation or PDE? What the meanings of partial differential equation? A partial differential equation this is the one of the types of differential equation. So I said that a partial differential equation, a partial differential equation, or in short we call it PDE, say that is an equation that containing one dependent variable, okay, and a partial derivative. Partial derivative. So containing one dependent variable and a partial derivative coefficients. Partial derivatives of more of 2 or more than two independent variables. This is the simple definition of partial differential equation. What's a partial differential equation? Is an equation that containing one dependent variable and the partial derivatives of 2 or more than 2 independent variables. Kwa hiyo tunasema partial differential equation tunasema kwamba ni aina ya partial, ni aina ya differential equation ambayo ina herufi mojawapo inayotegemea zingine, au ndani yake imeundwa na herufi mojawapo inayotegemea zingine, na minuko ya herufi zaidi ya mbili au zaidi ya mbili ambazo zipo kwenye hiyo equation. Tunaposema derivatives, tunasema kwamba manake tutaanza kudifferentiate au tutengeneze partial differential equation. Manake tunataka kwamba tuwe na function yenye dependent variable moja na independent variable mbili au zaidi ya mbili. Are we together? That's a very important concept that you have to understand. Notation, straightforward, because this is mathematics. Notation, mathematics is the start of number. Notation, how do we notate this partial differential equation? So the partial differential equations have, so he said that the partial differential equation has different notation. The prerequisite, different notations. The prerequisite of partial differential equation is function of several variable. Do you remember function of several variable? In calculus or engineering mathematics. That's the prerequisite. So we said that the partial differential equation, the PDE, this is the PDE, has different notations. So the following are some of the, so the following are some of the notation of the notations of PDE. The first one is this one. The partial differential equation is notated as partial of u with respect to x. Then partial derivatives of u, then with respect to y. Let's say we have partial derivatives of w square, so we have second derivative of w with respect to x with respect to y. Okay? Or you can find another partial derivatives that are third derivatives of with respect of v with respect to x with respect to y squared. Okay? So that's the one of the notation we should be using often. Also you can find that we have maybe a partial derivatives, the third partial derivatives of u with respect to x, with respect to y, with respect to z, etc., etc. Sometimes you can find that we have the second partial derivatives of u with respect to y, let's say square. Okay, so we have different ways of notating. Or maybe we can have the second, maybe the first partial derivatives of u with respect to x, but cubic, etc., etc. So this is the one of the notation. We have first order partial derivative. This is third order partial derivative. Second partial order, first order partial derivative. First order partial derivative. Second order partial derivative. Third order partial derivative. Third order partial derivative. Second order partial derivative, first order partial derivative. Right? That's the one of the notation. The second notation, I mean that is this one. The partial derivatives can be represented by using independent. So listen, we'll be discussing about dependent and independent. Remember that in this definition, we mentioned dependent and the independent. Simply, this is dependent. The numerator later, dependent. And this is the independent. Dependent, independent. Dependence, so you see dependence is 1, 2 independent. Then here we have 1 dependent, 2 independent. Or it can be 3. Depends on the questions, but it can be 2 or 3. Here we have 1 dependent, 3 independent. X, Y, Z. Then we have 1 dependent, maybe 2 independents. Okay? So another style, you see this one, u partial derivatives of u with respect to x, we can represent as u subscript of x. Then this one we can represent as u subscript of y. Okay? This one we can represent as what? W subscript of what? xy. Okay? Then this one we can represent as what? V subscript of what? X, Y, Y. This is another notation with the same meaning. Huh? Square is Y, Y. Then for this one, we say that it's U subscript of what? X, Y, Z. Okay? Then that one still be what? U, Y, Y. But what? Square. Mathematics is beautiful. Then this one is what? U, X, cube, etc. So in the question you may be given the partial differential equation in this notation, and you can change. Maybe this notation is comfortable for you. So you can change from this form to this form, or from this form to this form. And these are common notations that have been used in Tanzania. Right? Another form, we say that this one. Another notation, this is not common. We can find that it is this form. Look, look. So instead of u of x, you can find that we use this notation, f of x, but independent variable are x and y. Kwa hii ni function ambayo maybe differentiate with respect to x, lakini function hii independent variable yake ni x na y. Kumbuka hapa hatujui, tuna ux, hatujui kama hii inategemea ngapi, ila hii ishatuambia inategemea, hii function dependent variable inategemea variable mbili, ila kwenye hii hatuna detail. Sasa tumetajua variable moja, ila haiwezi kawa partial derivative au partial differential equation kama independent variable ni chini ya mbili. Yani manake ni moja. Ikiwa moja hatuiti partial derivative, tunaita ordinary derivative, na inatengeneza ordinary differential equation. So for the ordinary differential equation, we have one independent variable with one dependent variable. For the partial differential equation, we have one dependent variable with two or more than two independent variables. Sasa kwa notation hii inakwambia function independent variable ni x na y. Kwenye hii inakwambia tu kwamba huyu amebidi differentiate mara moja respect to x, lakini hatuambii kwamba je, hii u inategemea x, y, z, w au nini, hatujaambiwa. Tumeelewana? Then for this one you can represent how it can be maybe f of y, lakini pia anategemea x, y, labda z. Because remember, how do we differentiate the function respect to y for the multivariable? Well, we keep y, we keep x and z constant. Then differentiate respect to what? To y. Then again, here we are. We have w of x nini, xy. So for this one it can be w of x, y. Lakini hapa kwenye w tunasema tuna x, y. So are we together? It's just the notation. Then for u, we can say that we have u, x, y, z. Then what do you have? Maybe x, y, z. Then I just left this one. For v, it can be v of 40, x, y, y. Then this one can be x, y, etc., etc. These are just the important common notations. Okay? Right. So that's all about the first T. We are done with the first T terminology. Now we are going for we have discussed about first T terminology, the partial differential equation, and then we discussed about notation. how will he find? The good thing that those notations we will discuss them often. Okay? Most of the questions will be in that form. The second important parameter that we've mentioned in definition is called the independent variable. Class A independent variable. So this is, we are going to discuss about two types of variables that we are using in partial differential, which is independent and the dependent. Independent and the dependent variable. Independent and the dependent variable. Say independent and dependent variable. That's the terminology that we like to discuss. Then let us start with Roman A, independent variable. So what is independent variable? What is independent variable? So simply say independent variable of partial differential equation, independent variable of partial differential equation. So you say that independent variable, the independent variable say that is a variable which do not, or which is a variable which does not depend on another, on any other variable. So the independent variable is a variable which does not depend on any other variable. Kwa sema independent variable, hii ni aina ya variable ambaye yenyewe haitegemei variable nyingine kwenye equation. Does not depend on any other variable of the given partial differential equation. That's the definition. Example 1. So state the independent variable of the following partial differential equation. And the following partial differential equation is this one. The second partial derivative of u with respect to x with respect to t is equal to 2x minus 4t. Solution. Be careful on writing these partial derivatives. So this is the partial differential equation. Is it the first order or second order? Second order. So simply the independent, what are the independent variables in that equation? Independent variables are what? X and t. Very good. X and t. In partial differential equations or in partial differential coefficient, in most cases, the independent variables are denominators. Then, example 2. Example 2. So state the independent variable of the partial differential equation given below. So the partial differential equation given below, it is what? It is 5 partial derivatives of u with respect to y with respect to z plus e power x, then partial derivatives of x, y then. Then minus u 3 minus 3 u of x is equal to u of x y z square. So we've been asked to identify, to state the independent variable of the partial differential equation given below. Stop writing. So this is the coefficient. Stop writing. This is the coefficients of partial differential equation. This is the coefficient. This is the coefficient. Right? So then, what are the independent variables for these kinds of notation? The subscript of the equation. Right? So the independent variable for, according to this partial differential equation, it's y and z. According to this one, it is x, y, z. According to this one, x, y, z. So means that that partial differential equation contains 3 independent variables. So therefore, we say that the independent variable, so this is the solution, the independent variables are x, y, and z. X, y, and z. Example 3, the last example for independent variable. So state the independent variable, state the independent variable of the given PDE below. So the given, sometimes you might be given a trick question like this one. Then you have also partial derivatives of z with respect to with respect to v squared. This is equal to 1. And this was DIT Test 1 questions of 2015. So do you see the style of the question? Stop writing. Stop writing. So they say this is the kinds of the style of the equation. So its trick is, in previous examples, you may identify the independent variables within the single term. So for instance, here we have two independent variables. Here you have 2, we have 3, we have 3. But for this case, we don't have 2 or 2. So simply, it means that we use this term, the first term, and second term to identify what? To identify the variables. Okay? So use this term. So this is the first independent variable, this is the second. This is the first independent variable and this is the second one. This is U, this is V. So, yeah. But you see that it's tricky. You may say that the independent variable is 1, while there are 2. So for this differential equation, say the independent variable, independent variables are U and V. So you should not claim that U always is dependent, no? It depends. No need for you to claim. Right? It depends the differential, the partial differential equation that have been given. Are we together? Then now, let us discuss the second type, Roman B, dependent. So dependent variable. What is dependent variable of the partial differential equation? Then we say that the dependent variable, stop writing. The dependent variable, stop writing, is a variable which depends on other, or depends on independent variables. Depends on independent variables of the given partial differential equation. Because you said in partial differential equation, we have more than one. We have more than one independent variables. Okay? Yeah. So for instance, this will be example 1, state the dependent variable. So what the dependent variable for this differential equation? Huh? U. Yes, it's U. So dependent variable is what? Dependent. Independent X and T. So the dependent variable is U. Okay? Have you written this? Have you written this? Umeshaandika hii? Bado hii? Okay. Ngoja basi after andika zote. State the dependent variable. State the dependent. So this one will be example, let's say 4. This will be example of 5. So for this case, what the dependent variable? Yeah? Dependent variable ni variable ambayo inategemea independent variable. Kwenye mfumo huu nimekwambia dependent variable ni ile inayobeba subscript. Dependent variable ni ile inayobeba subscript. Hizi ndio subscript kwenye lugha ya kompyuta kama unakumbuka. Hii ni superscript. Kwa subscript zinakuwa independent variable. Inayobeba subscript ndio inakuwa dependent. Kwa hapo dependent variable ni nani? U. So the dependent variable is U. Kulingana na swali. Usikali kwamba dependent variable ni U siku zote. Right? Kwa hapa pia ukiandika utaandika swali lingine example. Okay, nadhani andika mpaka hapa. Write down. Called dimension of the partial differential equation. Dimension of the partial differential equation. Say dimension of the partial differential equation. Say dimension of the partial differential equation. So then let us define this terminology and then see examples. What is dimension? What is dimension of partial differential equation? So dimension of partial differential equation, we say that is the measure. So this the measure 40 is a measure of number of independence. The measure of the number of independent variables. Independent variables. So simply this is the measure of the number of independent variables present in the given partial differential equation. Kwa kimsingi tunasema kwamba hii ni parameter au tunaposema dimension ya partial differential equation tunasema ni idadi ya herufi zinazotegemewa kwenye hiyo partial differential equation. Kwa is a measure of number of independent variables. How many independent variables are present in the given partial differential equation? That's all. Actual, in the final exams or in the test exam, these questions or the questions of terminologies will be given at the list. Will be given maybe 10 partial differential equations. Then we ask you to identify dependent variable, independent variable, dimensions, order, degree, linear, non-linear, homogeneous, non-homogeneous, that is. So in lecture 3, I think that we'll be having typical type of those questions. And sometimes they provide even up to 10 marks in testing. And they are not just the normal partial differential equation. They are using different letters to confuse you. And if you didn't practice, they can give you contradictions or ambiguities in exam. Okay? So example. So example 1. So state what? So state the dimension of the given partial differential equation below. So partial derivative of u with respect to x, then this one q plus partial derivative of u with respect to x, then with respect to t. This one is equal to 2. Stop writing. So this is the partial differential equation, is it? Yes. How many independent variables do we have? Or what are the independent variables? So the independent variables are x and d, x and d, t. So independent variables are x and d, t. How many are they? 2. Therefore, the dimension of the given partial differential equation is 2. Basi. Kwa unaona, usipo zingatia na kujifunza unaweza ukachanganya. By dimension au kataja independent? Yes. Example 2. So state the dimension of of the given partial differential equation below. Partial derivative of z, partial derivative of y plus third partial derivative of u with respect to x, respect to y, respect to t. Then plus e power x, this one is equal to conj of x. Okay? So we've been asked to state what the dimension of the given partial differential equation, right? How do you state the dimension? First of all, we identify independent variables present in the given partial differential equation. What are independent variables that we have? For this one, we have y. Here you have x, we have t. This is the function, remember? This is the coefficient. This is the partial derivative. This is the partial derivative. First partial derivative, third partial derivative. Right? So for that case, so you may just write for your memory independent variable. So independent variables are what? X, y, and t. So simply say that, therefore, the dimension of the given partial differential equation is what? 3. Is it clear? Okay, so if it's clear, do you have any question about dimension? It's clear. Yeah. The first terminology is called the order of partial differential equation. We'll be using the abbreviations of partial differential equation, PDE, in most concept. Say order of partial differential equation. What is order of partial differential equation? What is order of partial differential equation? So the order of partial differential equation, the order of partial differential equation is the separating, is the highest. Physical students and online students, separating, is the highest. Say highest. Is the highest partial, the highest partial derivative. So this is the highest partial derivative present in the given partial differential equation. Nini maana yake? Sikilizani. Inawezekana kwa umepewa partial differential equation yenye partial derivative moja au mbili au tatu au nne au tano au sita. Tuseme kwa level yako ya shahada ya kwanza, mara nyingi unaweza kupewa partial differential equation yenye partial derivative 4. Kwa hiyo kwenye hizo partial derivatives au partial derivatives tunamaanisha hizi. Unaangalia ili upate order ya differential equation. Unaangalia kwenye hizo partial derivative labda moja au mbili au tatu au nne au tano ulizopewa kwenye hiyo differential equation. Ipi ambayo imefanyiwa au imebidi differentiated mara nyingi, hiyo ndio itakayokuwa inaamua. Ndio maana ita highest partial derivative. Highest partial derivative. Mfano kama hapa. Manake hii ni partial derivative ambayo imebidi differentiated mara moja. Kwa tunasema partial derivative hii kwenye differential equation tuna partial derivative mbili, moja, mbili. Hii may be differentiated, u may be differentiated respect to x mara moja. Na hii u may be differentiated respect to x na t mara mbili. Kwa hiyo huyu ndo highest partial derivative kwenye hii partial differential equation. Kwenye huu mfano pia, maana yake tuna partial derivative mbili. Hii hapa na hii hapa. Ukiangalia huyu na huyu, huyu may be differentiated mara moja. Hapa may be differentiated mara tatu. Sawa sawa? May be differentiated mara ngapi? Kwa hiyo huyu ndo highest partial derivative. Ndiye atakayeamua order. So simply, it means that in most of the partial differential equation, you will be given either one partial derivative, or two partial derivative, or three partial derivative, or four partial derivative, or five partial derivatives. Sometimes you will find that those partial derivatives have different different size of derivative. So if you're being given one, or three, or four, or five, then the partial derivative which has been differentiated several times, more than other partial derivatives, it's the one that will give you the order of the partial differential equation. For instance, in this partial differential equation, we have we have two partial derivatives. The first one, the second one. This one has been differentiated only once. Forget about this. This we'll learn the next time, which we call degree. And this one has been differentiated twice. Firstly, u has been differentiated respect to x, and then secondly, u has been differentiated respect to t. So this is the highest partial derivative present in this partial differential equation. For this case, we have this partial derivative, this is the coefficient, partial derivative, this is the function. So within these two partial derivatives, this one has been differentiated 3 times, and this one has been differentiated once. So this is the one that will decide the order. That the meanings of order of partial differential equation. I will give you examples. But for instance, this is the second order partial derivative equation, this is the third order partial differential equation. But I've just used the previous examples to explain the concept to you. Can I clean that? So let us see examples of order partial differential equation. So example 1, state the order of the given partial differential equation below. Separating, state the order of the given partial differential equation below. Number 1, or the first step, identify the partial derivatives are present in that differential equation. So this is the one of the partial derivative, this is the coefficient of partial derivative, this is the partial derivative, this is the coefficient of the partial derivatives, this is the partial derivative, this is the function. So the coefficient here is 1. Coefficient here is cos of x. Coefficient here is 3e power x, and the function is ln of x. So how many partial derivatives do we have here? 3. This has been differentiated how many times? Twice. And this one? Twice. And this one? Twice. So What the order? Huh? So the partial differential equation, we say that it is second order partial differential equation. Why? It has been differentiated. The maximum number, the highest order is 2. The highest partial derivative is 2. So we don't write the order of partial differential equation is 2. We use the word first order, second order, third order, fourth order, fifth order, etc. Example 4. State, example 2, sorry, the order of the given partial differential equation. Have another example. So in order for you to understand, you may do or you may use these examples just to review the previous concept. Stop writing. You may use these examples to review the previous. Hello? Stop writing. In order for you to store this concept permanently, you may use this given differential equation, however that you have been asked about order, but you may identify some previous terminologies. For instance, let us start. The first terminology that you have learned is called independent. How many independent variables do you have in this partial differential equation? Or mention the independent variables. X and Y. Here we have X, here XY, here XY. You are correct. Then how many dependent variables do you have? Okay, what is dependent variable? Not sigma. This is just, I want to know, to hear from you. How do you call it? This one, mathematics. This is called the psi. Psi. So the dependent variable is what? Psi. Then what are the dimensions of that partial differential equation? 2. Dimension is 2 because dimension we use the number. Then now the order. So to identify or to set the order of this given differential equation, first of all we have to identify the partial derivatives. First partial derivative, second partial derivative, third partial derivative. How many times is this partial derivative has been differentiated? Once. How many times has been how many times these partial derivatives has been differentiated? Twice. How many times is these partial derivatives has been differentiated? Twice. Okay, you are right for this one and this one, but this one you missed. This has been differentiated 3 times, thrice. To be differentiated, psi has been differentiated first time with respect to x. Psi has been differentiated second time with respect to y. And psi has been differentiated 30 times with respect to y. So which is the highest partial derivative? I'm asking a question. Which is the highest partial derivative? This one, the steady partial derivatives. So this is the one that make decisions, decide the order. right? Even if in this one, if we could have 4, remember that we don't use the power. We use the derivative. This 3 is completely different from this 4. So this is 2, this is the second order, but this is something else. We'll discuss the next terminology, the fifth terminology, which is called degree of partial differential equation. Are we together? So simply, how do we conclude? It's what? It is what? Third order partial differential equation. You didn't write there? Okay, now this is, let us solve example 3. State the order of the given partial differential equation below. This is actual that let us analyze, and this will be our last exam for this section. Then we'll go to the fifth and last terminology for this lecture, that is degree of partial differential equation. Well, so state the order of this given partial differential equation. Then I have mentioned the independent variables in that partial differential equation. X, Y, and t. Then mention the dependent variable in this partial differential equation. Variables. Yes, first of all, we made a mistake. Why we made a mistake? We have partial derivative of z with partial derivative of u. It's not possible to have two dependent variables. So correct from the previous example. So we have, so the dependent variable is z, not u. Ready? Okay, so if this is the case, we have to identify how many partial derivatives do you have? 2. 1, 2, right? How many times this has been differentiated? Twice. With respect to what? To y. How many times this z has been differentiated here? Thrice. Right? So which partial derivatives decide the order? The first or the second? Which partial derivative decide the order? Which is the highest partial derivative? The second partial? And how many times has been differentiated? Thrice or 3 times. So it is what? The given partial differential equation, it is what? It is 30 partial, say the order. Partial differential equation. Okay, then after that, I believe that you've understood the concept. Now let us discuss the fifth terminology. The fifth and last terminology for this, for the lecture 1, which is called the degree of partial differential equation. So this will be question number 5. What is degree? What is degree of partial differential equation? What is degree of partial differential equation? So the degree of partial differential equation, we say that is the power of the highest partial derivative present in the given partial differential equation. So the degree, stop writing. Class, say degree of partial differential equation. So you are looking for your first degree. So the degree of the partial differential equation, we say that is the power the degree of partial differential equation is a power of the highest partial derivative present in the given partial differential equation. Kwa tunasema, usikilizani sasa, degree ya partial differential equation tunasema ni kipeo cha pili, ni kipeo au ni kipeo kikubwa ambacho au ni kipeo cha partial derivative ambacho kipo kwenye equation iliyokuwa imepewa. Kwa hiyo degree ni tofauti na order. Order ni kwamba partial differential equation au partial derivative imebi differentiated mara ngapi. Degree maana yake kwamba kwenye zile power sasa, yani kwenye partial derivative, maana yake inaweza ikawa power 1 au partial derivative ikawa power 2 au ikawa power 3. Kwa ile maana yake power ndio inakuwa order, ndio inakuwa degree. So degree is completely different from what? From order. Because order, it measures how many times that differential equation has been differentiated. Actually, it's identified the highest partial derivative. Degree, we say that this is the power of the highest, not of the highest. This is the power of the partial derivative. Power of the partial derivative present the degree. A degree is the highest power. Is the highest power. Is the highest power of the partial derivative present in the given partial differential equation. Example 1. State the degree. State the degree. State the degree of the given partial differential equation below. Separating. So how do we state the degree of the partial differential equation below? First of all, identify partial derivatives. How many partial derivatives do you have there? How many partial derivatives do we have in this? 3. 1, 2, 3. Right? Then identify the power. So the power for this partial derivative is 1. The power for this partial derivative is 1. The power for this partial derivative is 1. What the highest power? 1. So we say that the degree of the partial differential equation is 1. That is, we don't say first or second or third. We just term it in terms of number. Example 2. State there. This is the goodness of partial differential equation. You use one example to teach different concepts. State the degree of the given partial differential equation. Separating. The first step, identify the partial derivative. How many partial derivatives do you have? 3. 1, 2, 3. And what the power of this partial derivative? What the power of this partial derivative? What the power of this partial derivative? So what the highest power? 4. So we say that therefore the degree of given partial differential equation is 4. Number 3, state the degree of the given partial differential equation below. How many partial derivatives do you have there? First of all, mention the independent variables in this equation. Variables. Only x, y. Independent variables.
Independent.
Yes. Independent.
X, Y, T. Yeah, X, Y.
X, Y, and D, T. Dependent? Z. Dimension? What are the dimensions of that equation? 3. Good. What the order of that partial differential equation? Third order. Well. Then now, what the power of this partial derivative? What the power of this partial derivative?
Power.
Yes.
1.
Not 3. Don't say that 3. 1. So this one is the one that gives us the degree. So the degree of the given partial differential equation is 3. Okay. So if that's the case, did you understand the concept?
Yes.
Yeah. So if you have understood the concept, I would like to say that this is the end of lecture 1, terminologies of partial differential equation. I would like to ask you for the online students to make decisions to be a serious online students, and you can register yourself free of charge on our official YouTube channel that's called Tanzania Online Institute of Technology, in square bracket Olenjolai. Just click the buttons that written subscribe for you to register yourself so that you can receive notification whenever we publish a new video. We have prepared and will be preparing a number of lectures about partial differential equation, or a number of lectures about advanced engineering mathematics and advanced calculus, and will be publishing or uploading every week. So make sure that you register yourself by clicking the buttons of subscribe so you can receive notification anytime, anywhere, whenever we publish a new video. And hence, I would like to ask you that to visit you on our official YouTube channel. Once you visit it, just go to the playlist and find the playlist which is written partial differential equation, or advanced engineering mathematics, or advanced calculus. So I would like to welcome in the next lecture, lecture 2, where I will teach you about other important terminologies we have in partial differential equation. And I can just mention in advance, those terminologies are called the linear partial differential equation, non-linear partial differential equation, homogeneous partial differential equation, and non-homogeneous partial differential equations. So they are very important concepts. We'll be learning about conditions, and we'll be solving questions from test 1, from test 2, mostly from test 2, from final exams, and supplementary exams, or end of semester exams, which have been assigned to undergraduate students of first year or second year students at the Dar es Salaam Institute of Technology. So I would like to ask you to join me in the next lecture, and invite also some of your friends to enjoy together the beauty of partial differential equation. It's one of the longest topic, and I want to tell you that it's one of the difficult topic in advanced engineering mathematics. However, that I'll try my level best to simplify and make it very interesting to you. So, welcome the next lecture. Thank you very much, and I thank God who have given me this chance. Welcome in the next lecture. I love you so much. May God bless you. Bye-bye. See you.